Your facility spent $2 million surrounding its perimeter with military-grade radars, thermal tracking cameras, and high-power radio frequency jammers. On paper, your airspace is completely sealed. Yet, inside the main turbine hall, high above $20 million generator sets, a 12-centimeter micro-drone drops through a rooftop ventilation louver. It carries no GPS receiver, transmits no radio telemetry, and ignores every jammer on your fence line. The moment a drone breaches the physical envelope of your building, your entire multi-million-dollar perimeter defense system becomes completely useless. Welcome back to BlackBox UAV. If your facility requires direct engineering analysis for internal industrial airspace defense, contact our team directly at BlackBox UAV at proton.me. Today, we are analyzing the physics of indoor drone infiltration, why reinforced concrete and steel sandwich panels create total radar blindness, and how to build a zero-interference indoor airspace security grid for critical manufacturing, data centers, and power plants. How does a micro-drone navigate inside a steel-reinforced industrial hall without a GPS signal or a human pilot? Through onboard visual inertial odometry and real-time spatial computing. Modern indoor micro-unmanned systems use downward-facing optical flow sensors combined with high-speed stereo cameras. By tracking high-contrast pixel displacement on the floor and walls at 200 frames per second, the drone calculates its relative position with sub-centimeter precision. Simultaneously, micro-solid-state LiDAR sensors project tens of thousands of infrared laser points per second, executing real-time simultaneous localization and mapping, or SLAM. The flight controller does not need external coordinates. It computes a localized three-dimensional vector map, autonomously navigating through structural steel trusses, cable trays, and overhead crane rails. Because the system relies entirely on passive optical perception, it emits zero radio frequency signals. Your external spectrum analyzers and radio direction finders register nothing. Where are the physical vulnerabilities in your industrial building envelope? Industrial facilities require massive air exchange and continuous logistics flow. This creates four permanent structural bypasses. First, HVAC intake plenums and rooftop exhaust louvers. Standard weather louvers stop rain, but their 30mm blade spacing offers zero resistance to a micro-drone. Second, automated loading dock doors. High-speed roll-up doors open dozens of times per hour, creating an open gateway for rapid indoor penetration. Third, industrial skylights and roof smoke vent hatches. And fourth, overhead pipeline and busbar penetrations between buildings. What can a 12-centimeter micro-drone do once inside? In an automated data center, dropping an ultra-wideband Rogue wireless tap directly onto an overhead cable tray creates a physical air gap breach into critical networks. In a high-voltage turbine hall or clean room, dropping conductive carbon strands or localized chemical contaminants triggers emergency equipment shutdowns, causing millions of dollars in continuous process disruption. Why can't security teams simply deploy indoor radio frequency jammers to neutralize these drones? Because indoor RF jamming creates severe electromagnetic self-destruction. When a multi-gigahertz RF jammer operates inside a steel-framed building, the electromagnetic waves bounce off structural metal, creating severe multipath interference and high-intensity standing wave patterns. This violates the IEC 61043 standard for radiated electromagnetic immunity. The intense RF energy induces parasitic voltages in unshielded sensor wiring, corrupts industrial Ethernet and Profibus communication frames, and causes emergency trips on delicate PLC systems. Furthermore, high-power indoor jamming instantly paralyzes your own automated guided vehicles, robotic assembly cells, and internal wireless telemetry. You cannot use a sledgehammer to solve a precision engineering problem. How do world-class automated facilities secure their internal airspace without risking technological downtime? By deploying an automated, non-disruptive indoor containment grid. First, install two-dimensional scanning planar LiDAR tripwires directly behind HVAC louvers, dock doors, and intake ducts. The microsecond a foreign object exceeding 5 centimeters breaches the intake plane, the system triggers high-speed motorized drop-down physical barriers, sealing the ingress point in under 400 milliseconds. Second, deploy an internal mesh of low-power ultra-wideband spatial anomaly sensors and passive acoustic arrays tuned to micro-drone motor frequencies. This provides exact indoor coordinate tracking with zero interference to factory automation. Third, implement non-destructive optical neutralization. High-intensity targeted stroboscopic arrays flood the drone's optical flow cameras with blinding light pulses. Deprived of optical feature tracking, the drone's VIO navigation collapses instantly, forcing a safe, controlled motor shutdown. Industrial security must not stop at the front gate. By sealing the building envelope and deploying intelligent indoor containment, critical facilities protect their core assets from low-altitude penetration. Subscribe to BlackBox UAV for clear, uncompromising defense and aerospace engineering analysis. Stay secure, and I will see you in the next breakdown.